Welcome to the part 3 of array implementation of stacks. In the previous presentation, we have learned how to implement the push operation of stack in C. In this presentation, we will learn how to implement pop operation of stack in C. So without any further delay, let's get started. So here we will see the program to pop an element from the stack. Now here is the stack ARR array and we have this top variable which is currently holding this value 3. You can see the capacity of this stack ARR. It can hold up to 4 elements, maximum 4 elements. Here you can see currently this stack ARR is full and now we are interested in deleting the topmost element of this stack ARR. This array is the representation of the stack, right? We already know this. This array is actually representing a stack and we are interested in deleting the topmost element of the stack. Now my question is how to delete the element at index 3. Obviously, we know that this is the topmost element and you can see the index of this element is 3. So my question is how to delete the element at index 3 or how to delete the topmost element of the stack. We cannot simply remove the array element. We cannot simply remove this element. Okay, we can replace it with some other value, but this is not a good choice. What we can do, we can still give the user an illusion that the array element is deleted by decrementing the top variable. Okay. So what we will do instead, we'll decrement this value by 1. This will give an illusion to the user that the topmost element is at index 2 instead of index 3. Top variable always keeps track of the topmost element of the stack. Isn't that so? It always keeps track of the topmost element of the stack. You can see that currently it is keeping track of the topmost element. You can see the top variable is holding this value 3. This indicates that the topmost element is at index 3, right? Now if the top is decremented by 1, then the user will perceive that the topmost element is deleted. Isn't that so? User will see that okay, top is 2. Which means that the topmost element is at index 2. Now user will perceive that the topmost element is at index 2 and not at index 3. Hence there is no element above this particular element, right? So in this way, we can mimic the behavior of removing the array element, right? Now we will write a pop function which is capable of deleting the topmost element of the stack, that is stack ARR, and returns the deleted element. We will write a pop function, a separate function for deleting the element. Actually, we are not deleting the element. We are just decrementing the top by 1. That's it, right? So pop function is capable of deleting the element and it returns the deleted element as well. Okay. It will not just delete the element, it will return the deleted element as well. Obviously, in this case, it will return value 4, right? I took this code from the previous lecture and here is stack ARR, that is our array, and obviously this top variable is also here and currently this is holding this value 3, which means that the topmost element is at index 3. Here you can see the series of push operations, right? After all these operations, obviously the stack will be full, right? And top will hold this value 3. Now, I'm interested in deleting this topmost element. I can delete this with the help of pop function. I'll declare a separate function pop and also define it, right? But we know that pop function will also return the deleted element. This means that it is important to store that value somewhere in some variable. That's why I have chosen this variable data and you can see that I have written this line of code data equals to pop and obviously these round brackets, right? So this indicates that whatever the value is returned by pop will get stored in this data variable, right? This is the representation of data variable. Now let me just declare the pop function over here. Obviously the return type of this function is int and it will not receive any value, right? Obviously it will give some value. And here in this function, first I will declare a variable value. I'll tell you why I have declared this variable. So let me just create a separate variable over here called value. After this, you can see I have put this line of code that is value equals to stack ARR top. Now with the help of this line of code, I will simply store this value in this particular variable. That's what I want, right? Stack ARR top will give me this value and I'll simply store this value within this value variable. As simple as that. So it will store this value 4. Now after this step, what I'll do, I'll simply decrement the top by 1. Here you can see it is important to decrement the value of top by 1 This will give the user an illusion that the topmost element is deleted and now the topmost element is at index 2. So let me just replace this by 2, right? And this is the only step required. After this, we'll simply return the value back to the main function, back to the caller. Here you can see this pop function will receive this value, and this simply means that data variable will receive the value 4, right? That's it. This data will receive value 4. So we have actually received the deleted element. Isn't that so? In this way, we can write a pop function, and now I think it is clear to you how pop function works, right? Now it is important to check the stack underflow condition as well. What happens if stack becomes empty? In that case, obviously there is nothing to delete, so we have to check the stack underflow condition. Therefore, it is important to write this piece of code in this pop function, right? Here I am checking this condition if top is equal to -1. This means that if stack is empty, then print this message on the screen, stack underflow, right? Which means that stack is empty. And I don't want to return any value, right, back to the caller. For this purpose, I'll simply call this exit function, okay? We don't want to return an integer. Exit1 means abnormal termination of the program. This simply means abnormal termination of the program, right? So exit1 means termination of the program with failure. As you can see, if this condition is satisfied, that is if top is equal to -1, this simply means that stack is empty. And we are trying to delete something from an empty stack. That's what we are doing here, right? But this is not allowed, obviously. This means stack underflow. And that is why I've called this exit function with this status, that is 1, which means failure, right? This is called abnormal termination of the program. After this, the program will get terminated, okay? So these 3 lines of code will not get evaluated after this, right? I don't want to return anything from this function after this if construct gets satisfied. That is why I have called this exit function with this status 1, right? Now I hope the idea of writing the pop function is clear to you. Now let me just execute this code in code blocks. Here you can see this is the complete code. We have this push function, we have this pop function, and we also have this print function. Actually, I want to print all the elements of the stack one by one. Here you can see first I am checking this condition if top is equal to -1. If at all it is the case that top is -1, then there is nothing to print. And this means we'll print this message on the screen, that is stack underflow. And then after this, you can see I have put this keyword return, which means that I just want to return back to the caller, right? And here you can see we have this for loop, which runs from I equal to top to 0, right? Actually, I want to print the elements from the top of the stack, right? So first the topmost element of the stack will get printed, then the second topmost element, and so on, right? So in this way, I want to print all the elements on the screen. And after this, I'm simply calling this printf function, which will simply print the new line character, right? That's it. And here you can see in this main function, I'm calling push 4 times. And here I'm calling pop twice. And after this, I'm calling this print function. Now let me just execute this code. Here you can see we got these 2 values, 2 and 1. Actually, initially we have all these values 1, 2, 3 and 4. The topmost element is 4. After calling the pop function, this element will get deleted. And after calling this function once again, this element will also get deleted. So this means that we are left with these 2 elements. And obviously the topmost element is 2. And then after this, the second topmost element is 1. That's why 2 will get printed on the screen first and then 1, right? This is quite simple to understand. Let me just remove these 2 pop functions. And let me just execute this code. You can see currently all the elements are printed on the screen. 4, 3, 2, 1. Okay. Let me just call the pop function once. Data equals to pop. Okay. And instead of calling print function, I will call printf function with %d in double quotes and data. Okay. I just want to check whether we have received this value, the topmost element, or not. Let me just execute this code. So you can see 4 is printed on the screen, right? So I hope this code is clear to you. Okay friends, this is it for now. Thank you for watching this presentation.